Hello. Today we are going to be reviewing your Linear Functions 3A study guide. So let's look at number 1. Tony is at her friend's house, which is 8 miles from home. If she can travel 1 mile per hour, how long will it take her to get home? Graph the function and then remember to label your x and your y axis. Okay, so let's label our x and y axis first to know how to graph this. So looking at our labels here, we have the miles from home, and we're talking about the miles from home per hour. So our miles are going to depend on the hour, so that means that our miles from home is going to be our y-axis, and hours would be our x-axis. Okay, so now let's graph the function. So notice how it says that Tony starts out at her friend's house, which is 8 miles from home. So this 8 miles from home is going to be the y-intercept. So the y-intercept is where it crosses out on the y-axis. So our graph is going to start up here at 8, because that is currently where Tony is at. Then, if she can travel 1 mile per hour, there's that word per, and that's your indicator that this 1 mile is your slope. So our slope is 1, but you also have to think about she's currently away from home, and she is trying to get home. So if she's trying to get home, that means that we should end up down here somewhere on the x-axis, because this 0 is going to represent 0 miles from home. So we are going to have a negative slope, okay? So our slope is -1. Remember, when you guys go to graph, you need to have your slope as a fraction so that we remember that we are rising -1. So that means we're going to go down -1, and then we are running 1. So that means you're going to go to the right one. Okay? So from this point, we're going to go down 1, right 1, and put a point. Down 1, right 1, put a point. And you're going to keep going until she gets all the way home. So when she gets all the way home, you would end up at 0 on the y-axis. Okay, so the question is wanting to know, how long will it take her to get home? Well, you can just look at your graph here. How long did it take her to get home? So here she was at her friend's house, Tony. All the way home would be at 0 miles from home. So how long did it take her? Well, it took her 8 hours. All right, now we are going to interpret our rate of change and interpret the y-intercept. So when you guys are interpreting your rate of change, you need to have your slope in your sentence, and you just need to identify what these numbers represent. So when you were going rising -1, when you were going down 1, that means that you were getting closer to home. And this 1 was representing your hours. Because as we know, rise over run is the same thing as the change in y over the change in x. So the y was miles from home, the x was hours. So when we go to start our sentence, I'm going to say for every hour, and then we just need to describe what happened. So for every hour, she got 1 mile close to home. Okay. All right, so now we are going to interpret the y-intercept. So our y-intercept was this 8 miles from home. So we just need to indicate that that 8 was talking about how many miles away from home she was. So in other words, where she started at, or the initial starting point of where she was at. So I'm going to put 8 miles from home was her initial starting point. All right, so really, guys, when you're interpreting the rate of change, you need to talk about both your x-axis and your y-axis, because your slope is representing both of them. For every something, something else happens. So you need to have both of your variables within there. When you're talking about the y-intercept, your y-intercept is only talking about miles from home, because you're only talking about this point right here of 8. So you just have to describe what that 8 is representing. And then using the words like initial or starting is really what you guys should have in your sentence. All right, number 2, determine if the function is linear or nonlinear. So remember, guys, linear means a straight line, or in other words, a constant rate of change. And your equations have to be in the format of y equals mx plus b. If you cannot get an equation in this format, that means that it's not going to be linear, okay? So like looking at this first equation, can we get this equation in this format of y equals mx plus b? And if you think about it, we could get rid of, or we could move this x so it's not in the denominator by like multiplying by x on both sides, but then you would just have xy equals 1, and you can't do anything else with that. So this equation would not be able to be in slope-intercept form. So this would be nonlinear. Another way that you can check this is creating a XY table. And you can just start plugging in any x values that you want. We're going to talk about using -1, 0, 1, and 2 in our next unit. So if you were to just keep plugging in numbers for x here, you can figure out what y is going to equal. So if you plug in -1, so 1 divided by -1 is just -1. If you plug in 0, you can't take 1 divided by 0 because that's undefined. If you plug in 1, 1 divided by 1 is 1. And if you plug in 2, 1 divided by 2 is just 1/2. So as you guys can see, there's not a constant rate of change within your numbers as well on the y-axis. So that's just another way to double check if this equation is linear or not. So we're going to say nonlinear because the equation cannot be in slope-intercept form. So your slope-intercept form equation is that y equals mx plus b. All right, next one. So graphs are super easy to determine if they're linear or not because you just need to look for, is it a straight line? So because it curves, it is nonlinear. And then you just have to say nonlinear because the graph is not a straight line. All right, and then when you guys are looking at a table, you just need to figure out if it has a constant rate of change. So does it have a constant slope? So remember, to find slope from a table, you're using your change in y over your change in x. So in other words, your rise over your run, okay? So your inputs are your x values and your outputs are your y values. So you just need to figure out, do your y values over your x values have a constant rate of change, okay? So like when we went from 2 to 4, that was plus 2. 4 to 6, that was plus 2. 6 to 8, plus 2. 8 to 10, plus 2. 10 to 12, plus 2. So since all of our y's were the same, our change in y is 2. And then looking at your change in x's, notice how they just go up by 1s every time. So your slope was constant because it was 2 over 1 every time. So when you have a constant rate of change, that means that it's linear. So our sentence is going to be linear because we had a constant rate of change of 2 over 1. All right, number 3, a climber is on a hike. After 3 hours, he is at an altitude of 250 feet. After 5 hours, he is at an altitude of 500 feet. Show all your formulas and work. So they want us to write an equation in slope-intercept form to represent the hiker's altitude at any given time. So if you look at this, really what they're saying is that at 3 hours, he's at 250 feet. So we can represent that as an order pair. Same thing with the next statement. After 5 hours, he's at an altitude of 500 feet. So again, you can represent that as an order pair. So if we need to figure out how to write an equation, y equals mx plus b, we need to figure out the slope. So when you have two order pairs, remember your slope formula of y2 minus y1 over x2 minus x1. So remember your first order pair is your x1, y1, and your second order pair is your x2, y2. So all that you're doing is you're substituting these numbers into the formula. So y2 is 500, y1 was 250, so 500 minus 250 over x2 was 5, and x1 was 3. All right, and then just solve it. So 500 minus 250 is 250. 5 minus 3 is 2. And when you simplify that, you get a slope of 125 over 1. Okay, so we just need to write that as our equation. So y equals 125x. Now we need to figure out what our y-intercept is. So remember, when you have any order pair and you have the slope, you can plug in these numbers into your equation and solve it for your missing value of b. So let's do that. So I'm going to pick the first order pair because those are smaller numbers. Remember, any order pair is x comma y. So I'm going to plug in 3 into x in my equation. I'm going to plug in 250 for y. And then we just found our slope to be 125. And then we're going to solve it for b. So first thing is simplify. So 125 times 3 gives us 375. And then last step to get b by itself is to subtract that 375 from both sides. So 250 minus 375 gives us a y-intercept of negative 125. So your equation should be y equals 125x minus 125. Alright, so next question is to predict the hiker's altitude after 8 hours. So now that we have our equation, 8 hours is represented by our x number. So I can just plug this 8 into x in my equation and solve it for y. So 125 times 8 minus 125. So when you take 125 times 8, you get 1,000, and then 1,000 minus 125 gives you an altitude of 875 feet. All right, number 4, use the given graph to interpret the rate of change and the y-intercept. So let's figure out what our rate of change is. Please be careful with how you guys are counting by, because notice how our graph is counting by 2's on the x and the y-axis. So remember, to find a slope of a graph, you're using rise over run. You're starting with the point furthest to the left, and you're trying to get from point A to point B. So I'm going to start here, and notice how I go from 8 to 12, or in other words, I rose to 4, so my rise is 4, and then you go over 1, so in other words, since you're counting by 2's, you're going over 2, because we went from 0 to 2. So reduced, your slope is 2 over 1. So your rate of change is 2 over 1. They want us to interpret. So your 1 is talking about hours, and the 2 is talking about temperature in degrees Fahrenheit. So remember, just like we did on the first problem, when you're interpreting your rate of change, you're going to start with whatever your x value is labeled down here is talking about. So you're going to say for every hour, and then you're just going to describe what happened. So for every hour, the temperature rose 2 degrees Fahrenheit. Alright, and then your y-intercept. So again, your y-intercept is where it crosses out on the y-axis. So notice how our graph starts here at 8. So that 8 is represented by the temperature that it started at. So you can say the initial temperature started at 8 degrees Fahrenheit. Alright, moving on. Number 5, the table below shows the amount of money spent at a carnival. The money spent is on admission for one person and the number of rides that person takes. So they want us to find and interpret our rate of change. So again, to find the rate of change from a table, you're looking at your change in y's over your change in x's. So they say that x is represented by rides taken and y is represented by money spent. So let's figure out what our change in y is every time. So when you go from 850 to 1075, that is an increase of 225. When you go from 13 to 1075, again, that is an increase of 225. And same thing when you go from $13 to $15.25. That is an increase of 225. So our change in y is 225 over your change in x. So looking at your change in x's, notice how they're just increasing by 1. So that means that your slope is 225 over 1. So the 1 is represented by rides taken, and the y-axis is talking about money spent. So you can say for every ride taken, it will cost $2.25. Next question says, what is the cost of admission for one person? So that means what is just the admission fee into the carnival without any rides taken. So in other words, they want us to find the y-intercept. So to find the y-intercept from a table, you just have to keep going back until your x value is 0. Because as you guys know, when your x value is 0, that whatever that y value, that is where your graph is going to cross out on the y-axis. So instead of adding 1 like we did to our x values, I could subtract 1 to get to 0. And to get back 1 on the y-axis, instead of adding 225, I could subtract 225 from 850. And that would give me my admission fee. So 850 minus $2.25 gives me $6.25. So your y-intercept, or in other words, the cost of the admission for one person without any rides taken, is $6.25. Alright, so now they just want us to write an equation to represent the situation. So remember, our equation is y equals mx plus b, where m is your slope and b is your y-intercept. So we said that our slope was 225. So our equation is going to be y equals $2.25 x plus our admission fee, so plus the $6.25. Alright, so last one here, predict how much it will cost to ride 6 rides. So to predict how much it will cost to ride 6 rides, since rides taken is represented by our x-axis, I'm just going to plug 6 into my equation and solve it for y. So we're going to take 225 times 6 plus 625. So if you take 225 times 6, that will give you $13.50. And then you're going to add that onto the admission fee of $6.25. And that is going to give you a grand total of $19.75. All right, number 6. Miguel, Susie, and Julian are saving their money to purchase a new bike. They all start with the same amount of money saved. The graph shows Susie's data. Miguel deposits $80 each time. Explain who has the greater rate of change. So in other words, who deposits more money each time. So they say Miguel deposits $80 each time. So his rate of change is that $80 over 1. To find Susie's rate of change, we have to look at the table and we have to figure out what the slope is. So she started at 50 and then her first deposit. Notice how we rose 100. We went from 50 to 150. So we rose 100 and we ran 1. So that means every time Susie is going to deposit $100 in her bank account. Alright, so who has the greater rate of change? Well, $100 is greater than $80, so Susie has the greater rate of change. Next question says the amount of money that Julian saves per deposit is between Miguel's and Susie's. So write a reasonable equation to show how much money Julian has in his savings account at any given time. So they said up here that they all started with the same amount of money saved. So they all started at your y-intercept of 50. So we know that our y-intercept has to stay 50 because they all started with $50 in their account. And then they just say to pick any number between 80 and 100 because they said that he deposits between what they deposit. So you can just pick any number. So I'm just going to go right in the middle, and I'm going to say he can put $90 in there. So since 90 was my slope, that's attached to my variable x plus our y-intercept of 50. So you could also say 81, 82, 83, just any number between 80 and 100. All right, circle all the points that are on the graph of this function y equals 3x minus 1. So in other words, if we were to plug in all of our x values here into x in my equation and I solve it, is it going to give me my y value? So for example, if we plug in 10 for x, 3 times 10 is 30, and then 30 minus 1 is 29. Notice how our y value is not 29, so that means that this point is not on the graph of that function. All right, so let's try the next one. So plug in 9 to x, because again, our order pairs are x comma y. So if I plug in 9, 3 times 9 is 27. And then 27 minus 1 is 26. And notice how our y was 26, so that is one of them. Next one, plug in 7. 3 times 7 is 21. Minus 1 is 20. So that one did not work. Plug in 4. 3 times 4 is 12. Minus 1 is 11. So that one did work. Plug in 6. 3 times 6 is 18. 18 minus 1 is 17. So nope, that one did not work. And then last one here, plug in 0. So 3 times 0 is 0. Minus 1 is negative 1. So that one is correct. All right, and then lastly here, they want us to state a different order pair that would be a graph on that function. So you can pick any x value that you want. Okay, your first number doesn't matter. So you just can't choose the same ones that they did up here. So I'm just going to pick a small, easy number here, and I'm just going to pick an x value of 1. So all that you have to do now is just figure out what your y value is. So when you plug in 1, 3 times 1 is 3, minus 1 would give me a y value of 2. So again, you can pick whatever x value you want. Just make sure when you plug it in, you solve it to get your y value. All right, last page. State the solution to the linear system of equations. So remember, guys, your solution to any linear system of equations is the point where they meet at. So the point where the two lines meet. And you just have to name that ordered pair. So notice how the two lines meet at this point. So if you find that ordered pair, it's negative 2 and then 4. So that would be letter B, negative 2, 4. All right, next thing is they want us to graph the linear system, and then state the solution. So remember, your first step is to always start at the y-intercept. So for my first equation, I'm gonna start at 4 on the y-intercept. And then you want to perform slope until you see where your two lines are gonna meet at. So usually when I do this, my first equation, I'm going to put as many dots as I can so that when I go to graph my second equation, it's going to be pretty easy to determine where my lines are going to meet at. So I put my y-intercept here at 4, and then now I'm going to keep performing slope. So if my slope is 5 over 2, as we know, slope is rise over run. So I'm going to keep rising 5 and keep running 2. So from here, I'm going to rise 5. So 1, 2, 3, 4, 5, and then run 2. And then I can also go backwards here. So instead of going up 5, right 2, I could go down 5 and then left 2. And then those are all my ones that would fit on the graph. There we go. And then now I need to graph my second equation. So our y-intercept is -3, so I'm going to put a point at -3 on my y-axis. And then again, I'm just going to keep performing slope until I see where my lines are going to meet at. So my slope is -x, so remember you can put a 1 in front of it. So in other words, your slope is -1. Remember though, you need to write it as a fraction to help you guys remember that you should also be running 1 still. So -1 means we're going down 1 and then right 1. So from this point, you can go down 1, right 1, down 1, right 1. But notice how we're not going to figure out, if we keep going that way, where it's going to cross that with this line. So we actually have to go backwards. So instead of going down 1, right 1, we're going to go up 1, left 1, up 1, left 1, up 1, left 1. And notice where these two lines are going to meet at. All right, so we just need to name the solution. So that order pair is at -2, -1. And remember, there's also a way to double check if this is correct by solving this. So you can set your two equations equal to each other. And then solve for x like normal. So I'm just going to add x over here, add x over here. So we're adding a 1x. So 5/2 plus 1 is 7/2 x. And then you still have your plus 4 equals -3. Subtract that 4 from both sides. So we get 7/2 x equals -7. And then multiply both sides by your reciprocal. And notice how you get an x value of -2. So we did do that one correctly. And then to make sure that your y value is correct, just plug -2 back into either equation and solve it for y. So -1 times -2 is a +2. So 2 minus 3 is -1. So notice how we did do it correctly. All right. Last question here is describe what a graph would look like for each type of solution in a linear system of equations. So for one solution, well, we just did that up here, the graph looks like kind of like an X, I guess you can say, but you just need to be a little bit more specific. So I would say the graph has two lines where they meet at a single point. So one solution, just like up here, there was two lines where they met at a single point. No solution, if you guys remember, are parallel lines. So you can say the graph has two lines where they never meet at a point. In other words, parallel lines. So parallel lines. All right, and then infinitely many solutions. You could say, so if you guys remember infinitely many solutions, you have two equations, but they're the same equation, so you pretty much just have one line. So you could say the graph has one line because the two equations are the exact same. So you really do have two lines, but it just looks like, because we're just trying to figure out what it looks like, it just looks like one line because they're both lying on top of each other. Okay? And that is your study guide. So if you guys have any questions, let your teacher know.